Hello guys, welcome back to my channel. Please remember to like and subscribe. Now today we're going to be talking about series. But let us go back to the two videos that we did before and talk about a sequence first. We said a sequence is a set of terms that follow a particular order or rule. And notice in this case, I am actually going up by 2. So we have 2, 4, 6, 8, 10. Now, what is a series? A series is really the sum of the terms inside of a sequence. So if we were to take these terms and we were to add them, let me call the series S. So the series produced from this sequence would be 2 plus 4 plus 6 plus 8 plus 10. So by adding the terms in a sequence, we actually produce what is called a series. Now there's a simpler way of writing a series. We can use what is called a sigma notation, right? Sigma notation. And this actually means sum of. So it's a Greek notation. So how do I generally represent a series? So taking, for instance, the same series, let me call it S equal the sum of. So it's the sum of the sequence AR from R equal 1 up to N. So what we're actually doing here is that we're saying that this is summing the sequence. And once you sum the sequence, it produces the series. R equal 1 means that I put 1 inside of this formula here to get the first term. We then put in 2 to get the second term. And we stop when we reach to whatever the n value is. So going back to this series here, 2 plus 4 plus 6 plus 8. S would be equal to the sum of, we're going from R equal 1. Now look at this carefully. Since we're adding 2 constantly, we know that it follows an arithmetic pattern. But because these are just multiples of 2, we don't even need the formula to figure out what this is. This is 2, 4, 6, 8. So it's just really 2R from R equal 1, and we go up to, we have 1, 2, 3, 4, 5. We go up to 5 terms. So to get the last term, which is 10, I would simply put 5 in the place of R. To get the first term, which is 2, I would put R equal 1 in the place of R. So that is how this formula works. Now here are some examples of a few questions. It says express the following in sigma notation. So let us start with A. So the first thing I need to do is to come up with a formula for these terms, 1, 8, 27, 64. If you notice, I'm not necessarily adding or multiplying by anything, so the geometric or the arithmetic pattern wouldn't necessarily help me. But these numbers are special, 1, 8, 27. If you look, they're all cubic numbers. So it would be the sum of R cubed from R equal 1. And notice we have 1, 2, 3, 4. We have 4 terms. Which means that to get the first term, we'll put 1 into the formula. And to get the last term, we'll put 4 into the formula. Alright, B. We have 3, 7, 11, 15. But also notice that there are 3 dots, which means that this goes on and on and on towards infinity. Now notice that I'm constantly adding 4. 3 plus 4 is 7, 7 plus 4 is 11, and 11 plus 4 is 15. Bear in mind from the previous video, we said that we can use a shortcut to do this. So we can say it's a sum, since we're going up by 4, write on 4R, and we manipulate this so that when we put in R equal 1, we get 3. So if I were to replace R with 1, I would get 4. To get 3, which is the first term, I would have to subtract 1. And since it goes on to infinity, we could simply put infinity at the top there, which means it goes on and on and on. Question C, we have 5 plus 7 plus 9 plus 11. Once again, I'm going up by 2, so we know that the arithmetic can help us here. But before we decide, well, we know what the formula is going to be. All right, so we have the sum. We know it's going to be 2R, but how do we manipulate 2R when R equal 1 to get the first term, which is 5? We would have to add 3. All right, and we're going from R equal 1, but I'm not sure where I'm going to stop. Because notice we have 5, 7, 9, 11. We skip out a few terms and we go up to 21. We could fill in these middle terms to figure out how many terms we have in all, but we don't need to do that because this formula, if I were to equate this to 21 and solve for R, it would tell me the position of 21. So we could have 2R plus 3 equal 21. So 2R would be equal to 18. We divide both sides by 2. R would be equal to 9. So I know that we have 9 terms overall. In fact, I know also that 21 is a 9th term. So it's a sum from r equal 1 up to 9 of 2r plus 3. And that's that. What about d? Now in d, we're not adding anything, but if you look carefully, 3, 9, 27, 81, we're constantly multiplying by 3 here. So we know we're going to be using the geometric pattern that says an equal ar to the n minus 1. Bear in mind from the first two videos we said that a is the first term, so it's going to be 3, and r is a common ratio, the n minus 1. And by laws of indices we can even break this down, because we have 3 times 3, the bases are the same, so we add the powers. So it's actually 3 to the n minus 1 plus 1, which is really 3 to the n. So in terms of sigma notation, since we want it in terms of r, we simply just replace the n by r. 3 to the r from r equal 1, and we have 4 terms. Now notice we could even write it in terms of something else. I could say the sum of 3 to the I from I equal 1 up to 4, since we had used r in the formula as a common ratio earlier, right? So this is just me rewriting it. It doesn't matter. Now a formula can also be given to you in terms of sigma notation, and you're asked to write out the series. So for example, write out the following series. In question A, we have the sum of 3r minus 1 from r equal 1 up to 4. What that means is that I'm going to be putting 1 inside of this formula first to get the first term. So we're going to be replacing this r by 1. So if we go 3 times 1, that would be 3, minus 1, that is 2. So I'm going to have 2 plus, we put 2 in there in the place of r, so it's 3 times 2, which is 6, minus 1, which is 5. To get the third term, we put 3 in there, so it's 3 times 3, which is 9, minus 1, which is 8. To get the fourth term, we put 4 in the place of r, so it's 3 times 4, which is 12, minus 1, which is 11. Now notice we can also pick up a pattern, because when we put in 2 and 5 and 8, we notice that we're going up by 3. So we could have actually predicted what the next term is going to be by just simply adding 3. But we know we're going to have 4 terms overall when we start from 1 and we go up to 4. For B is slightly different. What we have is the sum of r squared from r equal 4 up to 7. What does that mean? That means we're not going to be starting at 1. We're going to be putting in 4, then 5, then 6, then 7. Now if we put 4 here in the place of r, we're going to end up with 4 squared, which is 16. We put 5 in there, we're going to end up with 5 squared, which is 25, or we could just write it as 5 squared. We put 6 in there, we're going to have 6 squared, which is 36. And if we put 7 in there, we're going to have 7 squared, which is 49. Now notice that this says start from r equal 4, so 4 has to be the first thing you put inside of the formula. Which means now I now have 1, 2, 3, 4 terms. So how do I find a formula for how many terms do we have? We could simply say 7 minus 4, which is 3, and then we add 1, which is 4. So we can always use that to check to ensure that we have the right number of terms. It would also work at the top, but because we start from 1 up to 4, we know we're going to have 4 terms. But also if I said 4 minus 1 is 3 plus 1, I still end up with 4. Alright, so that is something to look into. Well, we can also talk about the n partial sum. The n partial sum is the sum of the first n terms of a particular series. And we're going to look at an example. So example, evaluate the sum of 2r plus 1 from r equal 1 up to 5. This is what is called the fifth partial sum, because it will be the sum of the first 5 terms. So we can first write them out. So we put 1 into the formula. It's 2 times 1 plus 1. That would give me 3. We put 2 in there. It's going to be 2 times 2, 4 plus 1, 5. And as we say, once we realize we're going up by 2, we can continue. So we have 3 plus 5 plus 7 plus 9 plus 11. So we have all our 5 terms, 1, 2, 3, 4, 5. So it says evaluate, which means now I'm going to have to add up all these numbers and put a final answer. So let's add them. This boils down to 35. Now a different way that I could have written the instruction is to say find the fifth partial sum. So we have to be very careful with how we interpret the different instructions.